Dual nature of matter and radiation. First of all, photon is a packet of energy and energy given by h nu. Nu is the frequency, h is the Planck constant, or h by lambda. Lambda is the wavelength. C is the speed of linear momentum of photon is given by h upon lambda. Photon is a neutral, rest mass is zero. If it is a neutral, they are not deflected either by electrical field or magnetic field, but they can be diffracted, allowed to pass through the narrow slit. Diffraction light का वही है, photon भी light है. So they are showing the effect of reflection, refraction, interference, diffraction, polarization. But here we are discussing the particle nature, not the wave nature. And particle nature we are discussing photoelectric. There are some terms here. Intensity, the energy of the number of photons striking the surface per second per unit area. Intensity here n h nu, n is the number of photoelectrons per second, and h c by lambda, n is the number of photons falling the cathode per second. Unit of intensity is joule per second per meter square. Joule per second is watt per meter square. Work function. Here work function is the either denoted by phi naught or W naught. It is the minimum energy required of the photons emit the electron from the metal surface. Threshold frequency, the minimum frequency required to emit the electron from the metal surface. Threshold wavelength, this is the maximum wavelength of the photon required to emit the electron from the metal surface. तो फॉर्मूला है इंटेंसिटी h nu, एक फोटोन की एनर्जी हो जाएगी, नंबर ऑफ फोटोन पर सेकेंड, ये h by lambda रेसिप्रोकल. यहाँ पर हम लोग कहेंगे कट ऑफ वोल्टेज या स्टॉपिंग वोल्टेज इज द मिनिमम नेगेटिव वोल्टेज ऑफ एनोड विद रेस्पेक्ट टू रिक्वायर्ड टू स्टॉप द maximum kinetic energy of photoelectrons. It is also called cutoff voltage because at this voltage there is no current flowing in the circuit. इसलिए इसे cutoff voltage भी बोलते हैं. Now, photoelectric effect is the phenomena of ejection or emission of photoelectrons from the metal surface due to the suitable photons. Suitable photons means energy of photon must be more than the work function, so that it is ejecting the electron from the metal surface. H nu is more than H nu naught, or frequency of photon is more than the threshold frequency. It is ejecting the electrons from the metal surface. This is called photoelectrons, and current flowing the circuit, photoelectrons, is called photoelectric current. This is the experimental setup here. For that we are discussing the Einstein's photoelectric equation. H nu is equal to work function plus kinetic energy half mv square maximum value. In this equation it is shown kinetic energy maximum, although the same photon ejecting the electron from zero kinetic energy to maximum, but यहाँ इक्वेशन में मैक्सिमम शो. इसी एक ही इक्वेशन को हम तरह तरह से लिख रहे हैं, लाइक h nu is equal to work function plus E V naught. V naught is the stopping voltage. h nu naught plus kinetic energy या E V naught. तो हम वेवलेंथ में भी लिख सकते हैं h c by lambda is equal to work function plus kinetic energy या E V naught. तो एक ही इक्वेशन को हम तरह तरह से लिख रहे हैं. So this is the arrangement. This is the arrangement here. This is the evacuated chamber, and photons are falling. Suitable photon means energy of photon must be more than the work function. They are falling on the cathode, and electrons are ejecting, moving from cathode to anode. Node is positive, so they are attracting. In this way, current is flowing in the opposite direction, can be measured by this microampere. And here this is the arrangement, potential divider. Here switch or key K1 and K2, positions of K1, K2 with this. Suppose here adjacent K2 is what, positive to anode, and K1 is negative to cathode. And suppose we move K1 left, K2 right, the difference of voltage means anode voltage decreasing with respect to cathode. Suppose K1, K2 are overlapping, then zero anode voltage with respect to cathode, and K2 अब इधर आ गया तो नेगेटिव हो गया, and K1 इधर तो पॉजिटिव. So anode voltage with respect to cathode can be made negative also, can be varied also. So this is the schematic diagram of photoelectric effect circuit diagram. Now, if the frequency is less than the threshold frequency, there is no ejection emission of electron. If frequency is equal to threshold frequency, electrons are ejecting but zero kinetic energy. If frequency is more than the threshold frequency, photoelectrons are ejecting but non-zero kinetic energy. Same photons ejecting, electrons ranging from zero kinetic energy to maximum. In Einstein equation showing the maximum kinetic energy. Only one photon can eject only one electron. Now, laws of photoelectric effect. Here, if n is the number of photons per second increases, it means number of photon increases, so one electron ejecting by the one photon, so number of photoelectrons also increases, reaching up to the anode, so photo current is also increases in circuit diagram. Intensity is h nu, एक photon की energy multiplied by n is the number of photons per second. So this intensity can be written as nhc by lambda. N and energy of one photon. h nu में लिखो चाहे hc by lambda. N is the number of photon per second. यूनिट इंटेंसिटी का हो जाएगा जूल पर सेकंड पर मीटर स्क्वायर या वाट पर मीटर स्क्वायर. इट मींस अगर इंटेंसिटी इंक्रीज करेंगे नंबर ऑफ फोटो इलेक्ट्रॉन्स इंक्रीज होंगे, नंबर ऑफ फोटोन इंक्रीज होंगे, तो वो 5 एनोड तक पहुंच के करंट भी इंक्रीज हो. सो करंट इज डायरेक्टली प्रोपोर्शनल टू इंटेंसिटी. सो दिस द ग्राफ डायरेक्टली प्रोपोर्शनल. सेकंड ग्राफ or second law, effect of intensity on photo current, keeping the frequency constant. Here, if there is no positive voltage, anode voltage 0, even then we are getting some current. The reason here, photon की एनर्जी हमको किसको मिल रही है, एक तो एजेक्शन में निकल गई, जो बाकी बची वो काइनेटिक एनर्जी आ गई. So we are getting some current, not zero current, even if anode voltage 0 with respect to cathode. If we are increasing the voltage little bit, current is increasing, but after a large value of anode, there is no increment in the current. That is called saturation current. जितने भी हमारे photons eject हो रहे हैं सबको कलेक्ट कर लिया, so there is no now chance to increase the current. This is the maximum value called saturation current. If intensity increases, saturation current also is. Now, on the other hand, there is the equation H nu is equal to work function plus EV naught. So, stopping voltage depends on frequency, and here frequency is constant, so stopping voltage is also constant. चाहे intensity कुछ भी हो, stopping voltage change नहीं, only saturation current change हो रही. For the region here, P0, non-zero current, we have discussed this. Electrons are reaching up to the anode because of their energy supplied by the photons. If potential increases, current also increases up to the saturation level. Stopping voltage, negative voltage is required here to stop the kinetic energy maximum and current becomes 0. But frequency is constant, so stopping voltage is also constant. This is the graph or second law of photo effect. Now, suppose here, there very important point here. Saturation current depends on intensity and not on the frequency of incidenting photons. And stopping voltage V naught depends on frequency, not on intensity. Now in third graph or third law of photoelectric effect is effect of frequency on photocurrent keep the intensity constant. If intensity constant, the saturation current be constant. If frequency increases, if frequency increase, energy increase, so stopping voltage increase. Means frequency nu3 is more than nu2 is more than this, so stopping voltage V03 more than V02 is more than V01, as we can see here in graph. So frequency increases, stopping voltage increases, kinetic energy increases, but saturation current remains the same because intensity is same constant. The question here many times asked in the CBSE board, if frequency becomes double, then kinetic energy will become more than double. क्या रीजन है इसका? Is the work function is constant. Work function double नहीं हो रहा. The fourth point, the collision of photons with electron is elastic collision. Means there is no loss of kinetic energy, and this process is taking place. What is the time? Time is taking only nanoseconds. So this is instant process, no time delay. The action of electron is immediate. Now explanations of laws of photoelectric effect. Since one photon can eject one electron only from the metal surface, number of photoelectrons emitted depends on the number of photons means intensity. From Einstein equation, we take that the frequency is less than the threshold, no ejection. Current energy negative, not possible, so there is no ejection of electrons if the incidenting frequency is less than the threshold frequency. Third point, maximum current energy photoelectron depends on the frequency or wavelength. Intensity तब इंक्रीज करें, नो चेंज इन द स्टॉपिंग वोल्टेज बिकॉज स्टॉपिंग वोल्टेज नॉट डिपेंडिंग ऑन द इंटेंसिटी. It depends only on the frequency, and there is no time delay between the incidenting photon and the ejected electrons called photoelectrons. There are some important graphs here between the kinetic energy maximum and the frequency. By this equation we can say h nu equal to work function plus kinetic energy maximum. So frequency and kinetic energy maximum, they are directly proportional, and below this x-axis there is no graph exists. Reason behind here is this is the threshold frequency for A, threshold frequency for B. If the less frequency than the threshold, there is no ejection. So this graph is not existing at all. We are deliberately extended this graph. So here we are getting the work function. Frequency 0 करेंगे, इस इक्वेशन में क्या मिलेगा? Kinetic energy is what? Negative work function. Say if the frequency increases less than the threshold, no current, and after that current increases. If intensity is constant, current is also. Kinetic energy stopping voltage, it does not depend on intensity. We have discussed this. Say it is taking the nanosecond time, after that we are getting the current. Nanosecond time is very, very small. This is a very important graph here. We have already discussed this one. Stopping voltage versus frequency. Same graph we have discussed for kinetic energy and stopping voltage. Are equal. EV naught is equal to what? Kinetic energy maximum. So this is the graph for metal A, for metal B, and this is the frequency threshold for A, this is the frequency for threshold for B. Extended this, we are getting the y-intercept, work function divided by E electron charge for B also. If the frequency, threshold frequency for B is more, then work function will be more for B than A. If work function is more, y-intercept is more for B than A. Here, for a given metal, V naught varies linearly with the frequency, but below this threshold frequency, there is no graph existing here. Stopping voltage required 0. Higher the work function, greater is the value of threshold frequency, like this, and y-intercept is given by work function divided by E electron charge. Work function is h nu naught or hc by lambda naught. Nu naught is the threshold frequency, lambda naught is the threshold wavelength. This is the minimum, this is the maximum. And slope of all the curves, h by is constant. So theta is tan theta slope, theta also. Mathematically we are deriving, or we are just justifying this. This is the equation, h nu is equal to work function plus E. If we differentiate here with respect to NC both sides, we get h nu का बन जाएगा 1, work function constant है, so 0, E dV naught by d nu. This is called slope of this curve, tan theta. So this is a constant quantity, slope is a constant quantity, so tan theta is constant quantity, so theta is also constant quantity. So slope or theta is same for both the metals or any metal. Slope is same, theta is same. Now this is also repeated question. Failure of wave theory to explain the particle nature. Here photoelectric effect means photoelectric effect cannot be explained by the wave theory or laws of theory. Here point number 1. As per the wave theory, energy carried out by the beam of light is measured in terms of intensity. If the intensity of light is increased, there will be increment in the amplitude of the wave, and hence energy is carried by the wave is increases. It means kinetic energy of ejected photoelectron depends on the frequency of incident. This radioactive, but this is not the case in case of the photoelectric effect. But kinetic energy is not depending on intensity, it depends only on frequency. So this is the failure of wave theory. Now point 2. The photoelectric emission possible for the metal by the wave of light of all frequencies, provided the intensity of the light is sufficient to provide the required energy. But here, if the frequency is less than the threshold frequency, there is no ejection. So photoelectron emission depends on frequency, not on, अगर frequency कम है threshold से, इंटेंसिटी हो जाए किसी लार्ज वैल्यू के लिए भी रिएक्शन नहीं होगा. द वैल्यूएशन ऑफ वेव थ्योरी. नाउ 3. When the light falls on the metal energy of wave, its light still will not be go to a particle of electron. When a light falls on a metal, energy of the wave of light will not go to the particle, but will be distributed to all electrons. As a result, electron will take some time to accelerate, to accumulate the energy required. But in photoelectric effect, there is no time delay. Immediate projection of photoelectrons, and only one photon ejecting or that energy transferred to only one electron, not to all. So this way, wave theory cannot explain the particle nature. Now, wave has dual nature. Wave has dual nature. Particle nature as well as wave nature. De-Broglie suggested particle must have the same dual nature also. Particle is particle, but particle is producing the wave called matter wave. As per the de-Broglie wave, lambda is h upon mv, where m and v are the momentum. If velocity is 0, wavelength becomes infinite. If velocity is infinite, wavelength is 0, but both the cases are not wave. It means v cannot be 0, cannot be infinite. So v must be finite. Means only finite moving particles can produce a wave, whether charged or uncharged. When neutral particle is moving, it is producing the wave. So derivation of from the Planck quantum theory, energy is h nu or hc by lambda. Einstein mass energy equation is equal to mc square. Both are energy, so equation 1, 2 and 3. This equation 2, this 3. दोनों को इक्वेट करेंगे, then c कैंसिल हो गया, h by lambda is equal to c mc, so lambda is equal to h upon p. This lambda is called de-Broglie wavelength. This de-Broglie wavelength. It means if particle is moving, it is producing a wave whose wavelength is given by this formula equation 4 called de-Broglie wavelength. Kinetic energy can be written p square by 2m. So p is what? Under root 2m ek. Ek is the kinetic energy. Putting in equation 4, lambda h upon p की जगह लिख देंगे under root 2m k. और एनर्जी को हम लिख सकते हैं 2 into v. Q is the charge, v is the potential difference. Equation 6 means if we are taking the case of electron, here mass of electron, charge of electron, v is the voltage. Putting all the values of Planck constant, mass of electron and charge of electron, this is the answer. Photon for electron का हमारे पास, so this is the wavelength for electron excited by voltage v. The wavelength is given by 12.27 upon under root v angstrom for proton. Proton का charge, proton का mass. Putting all the values here, mass and charge, and so this comes here 0.286 upon under root v angstrom. For neutron also, although this is not a charged particle, but it is moving, so it is producing a wave. But it cannot be accelerated by the voltage, but by any other means. If it is moving with same velocity, same kinetic energy, same, then we can find out the wavelength by this equation. K is the kinetic energy of neutron, although not accelerated by the potential difference. For deuteron, mass of deuteron, charge of deuteron, putting these values, we are getting here lambda for deuteron is 0.02 upon under root v angstrom. For alpha particle, mass is 4 times than proton, charge is 2 times than charge of proton. Putting these values, we are getting lambda for this alpha particle 0.0101 upon under root v angstrom. Here the ratio lambda of photon upon lambda of electron, c by e root 2 mk. That k is the kinetic energy of the electron, is the energy of the photon. The ratio from kinetic energy theory, ek kinetic energy is given by 3 by 2 and root 3 by 2 kBt. Ek is equal to 3 by 2 kBt. Kb is the Boltzmann constant, is the temperature in Kelvin. So this is the wavelength produced here. 1 by h upon under root 3 m kBt. Mass of the particle, kb is the volt, temperature in Kelvin.